Hi guys, welcome to Math Bootcamp Part 2. Today we are going to be talking about units and unit conversions. So in life, throughout human history, as well as in science, there are many applications where we need to be able to measure quantities. Some examples, very simply, of where that might be necessary could be the amount of material or how much stuff you have for millions of different reasons. Could be the amount of chemical that you need for a reaction. It could be the amount of tomatoes that you're buying in the supermarket, how much rocks or concrete you need for a building project. It could also be cost, how much of something you have in order to attribute a cost to it, or how much something is valued at. Distances, how far things are from something else, how long something needs to be in order for a building material, a distance that has been traveled, a distance on the map to set boundaries, many examples. And as well as time, how long something takes to complete, the amount of hours someone has worked, etc. All of these things are just a few examples of, again, the countless reasons that we need to, in both science and just in society, be able to measure different quantities. For that reason, thousands of years ago, scientists came up with a system which is called units. Units are simply a standard, or always the same, and defined means of measuring and comparing different quantities. So with units, we can't just say, oh, I have one bucket of dirt, which is worth X amount of whatevers. We now, with units, can say, I have 10 grams of dirt, which is worth $17. So this is all units are, is a standard means of measuring and comparing these different quantities. Now, there are many different quantities that we can measure. We've even talked about a few here. However, there are three that are what we call the fundamental quantities. In science, these are the units or the quantities which come together to make up many of the other quantities that we will need and utilize in science. For that reason, we're going to focus on these three today and learning about their units. These quantities are length, mass, and time. Now let's look at the units for these three fundamental quantities. In science, we use what is called SI units. These are the set of units that are standard and agreed upon by scientists. So in science applications, we use the SI system of units. Now let's look at what the SI units for these three fundamental quantities are. For length, our SI unit is the meter. The meter is represented with a lowercase m. As a review from math class, but worth stating here, you should know that area and volume are both functions of length. So in order to get the area or a volume of anything, it is a function of the length quantity. Area is a squared length quantity, whereas volume is cubed. For that reason, the SI unit for area is the square meter, or the meter to the second power, and the SI unit for volume is the cubic meter, or the meter to the third power. The SI unit for mass is the kilogram. You may also hear it said as the kilogram. That is represented as a lowercase kg. And finally, the SI unit for time is the second. This is one that we are all familiar with. The second is represented by a lowercase s. Within the SI system of units, there is also what we call SI prefixes. These are small segments of a word that come in front of the base unit, which describe a multiple of the unit. So how many parts of that unit there are in this new subunit with the prefix. By placing the prefix in front of the base unit, we get a new unit or a subunit, which is either larger or smaller than the base unit. If you look here in the table, I have provided you most of our common SI prefixes, but let me tell you which ones are most important for you to be familiar with for this class. You want to be familiar primarily with the centi prefix. Centi, represented by a lowercase c, represents 0.01 or 10 to the negative 2, which means 1/100th of the unit. So a centi means, again, that it is 1/100th of that base unit. You also should be familiar with the kilo prefix. Kilo represents 1,000 or 10 to the third power of the base unit, meaning that there are 1,000 of that base unit. Let's look at an example here. If we look at a centimeter, let's find our centi prefix here. This is one of the ones that we want to be most familiar with. We can see here again that the centimeter is 0.01 or 10 to the negative second power of that base unit. So by putting centi in front of the meter, I know that a single centimeter is 0.01 meters or 1/100th of a meter. That means also that there are 100 centimeters in a given meter. Now, because units provide us that standard or defined means of measuring a given quantity, it then makes sense that we can only compare two quantities which are in the same unit. This is like the saying, comparing apples to oranges. You can't compare apples to oranges because apples are not oranges. It works the same in units. I cannot compare centimeters to meters because a centimeter is not a meter. In order to make a comparison between two quantities, they must be within the same unit. To give you a real world example, I wouldn't tell you I have $1 and you have 1 penny, so we have the same amount of money. I can't compare the 1 to the 1 because they're not in the same unit. In order for me to make that comparison, I need to do what is called a unit conversion, meaning that I need to take one of those quantities and convert it or change it into the unit of the other, or the desired unit that I want, in order to make that comparison or to use it in a calculation. Now, there are two ways of doing unit conversions that we are going to discuss today. The first is called the ladder method. The ladder method is used for converting between different subunits of the same base unit, meaning the base units with their given prefixes. For example, comparing centimeters to millimeters to decimeters, etc. So within the same base unit, converting between those different prefixes, we will use what is called the ladder method. So as you can see here, we have our base unit at the middle, and then we have our prefixes that are larger than the unit and our prefixes that are smaller than the unit. By using these steps of 10, you can see here, they all move one single decimal point. We can convert easily between these different units. So our first step is to determine your starting point, meaning, are you at the base unit? Are you at deci, centi, milli, deca, hecto, kilo, etc.? Your second job is to count the number of jumps. This means the number of decimal points from your starting point to your ending point. You then simply want to move the decimal the same number of jumps in the same direction. So to convert to a smaller unit, you want to move the decimal point to the right. This is carrying out a multiplication. To convert to a larger unit, you are going to move your decimal point to the left, or a division. So if we look at an example here, if I want to go from 4 kilometers to meters, how would I do that? Well, if I'm at a kilometer, I'm here, which is 1,000 of that base unit. I know if I want to convert to a smaller unit, which a meter is, I need to move to the right, or I need to carry out a multiplication. I then need to count the number of steps, or the number of decimal points from the unit that I'm at to the desired unit. From kilo to the base unit of meter, I can see here that I have 1, 2, 3 steps on my ladder. And again, this is 3 steps to the right. I will then take that quantity of 4 and move the decimal point 1, 2, 3 points, or 3 spaces to the right, which leaves me with 4,000 meters. I've also included here some helpful diagrams that you would probably benefit from either printing and gluing into your science notebook, or simply recreating within your science notebook. The next method of conversions that we're going to learn today is the Chemist Method. The Chemist Method can be used with the prefixes in place of the latter method if it is easier for you. However, the Chemist Method is most useful for when converting between different base units. So, for instance, between pounds and kilograms. They are not the same base unit, therefore we cannot simply move decimal points in order to convert between them. With the Chemist Method, what we are trying to do is start with the unit that we have and use conversion factors in order to cancel out unwanted units until we are left with just our wanted unit. Now let's look at this example and make the conversion using the Chemist Method. It's asking us to convert 37.8 pounds into kilograms. We've been given the conversion factor of 1 pound being equal to 0.454 kilograms. So the first step of the Chemist Method is always to start with what you have, or the unwanted unit. In this case, we are starting with 37.8 pounds, which is what we want to convert from. So we'll always start with, the unit that you have, which again, in this case, is 37.8 pounds. Our next step is to look for a conversion factor between the unwanted unit and the unit that we want. In this case, we do have a direct conversion factor from kilograms to pounds. Now we just need to make sure that we plug that conversion factor in correctly. So we know that our job is to try to cancel out the unwanted units and leave us with only the units that we want. In this case, my unwanted unit is in the numerator. So in order to cancel it out, I know that it needs to be placed in the denominator. Then that leaves me with the other part of my conversion factor, which is kilograms. I then want to place that in the other half of the fraction. All I need to do now is plug in the values of the conversion factor. In this case, 1 pound is equal to 0.454 kilograms. Now let's see what's canceled out. I know that if I have something in the numerator and the denominator, it cancels out. So in this case, I've canceled out pounds. That leaves me with only kilograms, which is the unit that I want. In this case, it was a one step, so I am completely finished. All I need to do is carry out the math to get my final answer. In this case, I would multiply 37.8 by 0.454, leaving me with 17.16. And we know that the unit that remains is kilogram, which is what we wanted. If you need more examples or you'd like to see more complicated conversion examples, please check out the next video of conversion examples.